Speaker is Waleed Akbar. He will present automating the management of IP over DWDM networks. So thank you, Waleed.
Thank you, Regan. Hello, everyone. My name is Waleed Akbar, and I am working as a researcher in CTTC. Today, I am going to present about automating the management of IP over DWDM network. With mostly my focus will be on how we are going to achieve the automation inside the TFS based on the ZSM framework from ETSI. So first of all, I will just give a small overview about what is IP over WDM. IP over WDM directly integrates IP routers with WDM network with pluggable transceivers. This means enabling the direct transmission of data packet via optical network. So it will bring the advantages such as it will reduce the cost, it will reduce the latency, as well as it will offer a flexibility. Here you can see on the top, we have IP layer where we can create a virtual network and the virtual links. And actually the physical links will be created at the bottom at the optical network. What is the network automation inside the network? The network automation is a continuous cycle of observation, analysis, and the optimization, the use of network resources in real time. Well, you can say without human intervention because we want to achieve this thing. And it will give you scalability in sense of network management. It will provide a service agility. It will give you more reliability, as well as it will enhance the security and the compliance of the service level agreements. Okay, so this table is about how we want to achieve the network automation, or we can say the fully autonomous network in future. So if you see on the top, the first layer will provide you a step-by-step guideline. How can we achieve the future network automation inside the network? What is our goal also in TFS to provide a full automated network support? And on the first column, we can see some of the dimensions that should be automated one by one. First of all, if you can see, we have a context awareness analysis that is important if that is about the data collection and the analysis. First of all, if you want to achieve the fully network automation, the first thing that should be automated inside the network is the data collection and the real-time analysis of the data collection. So that should be automated first. That's why you can see in the level one, we are first thing that need to be automated is the context awareness. And then we are moving towards the second level of automation. In the second level, the automation is non-real-time prediction and inference. Why is that? If we are able to do the non-real-time automation, this will give you a baseline for the network, how the network is working in normal state. And if there is a anomalous traffic, this should be able to detect it. And in this way, you are able to understand that in which level your network works, what is the quality of the network when it is working in normal state, when it degrades, what happened with the networks. If you're able to define these conditions, then the next step should be to decide and to execute making decisions. So if you are able to understand, if your machine system is able to understand how you're not working, how your network is working normally, and how your worker behaves when it is anomalous traffic inside the network. In this case, then we can say that we can give our decision power and the execution powers to AI, that it can make the decisions and it can execute these decisions inside the network. Okay, once we have this automation inside the network, then we can go to the next level of automation, that is real-time prediction and inference. In real-time prediction and inference, the network should be able to get the anomalous traffic, or to get the data, to get the network state that is not according to the normal state, and try to resolve this problem in a real time, and also apply the new configuration inside the network and try to mitigate this problem. And after that, the last thing that it should be the exceptional handling. The exceptional handling also need to be added inside the fully autonomous network. If you want to achieve the fully autonomous network, each and every part of the network should be automated. And it should be automated in this way In this way, you are able to achieve step-by-step automation. At the end of the automation, you will have a fully autonomous network, and this is our goal that we want to achieve inside the TFS to provide the full support of the network automation. At the bottom, you will have some features that will say what are the features that need to be automated. First of all, you can automate the rule-based automation that can be applied. As we move forward, we will have an open loop. Some of the things are automated, some of the things are manual, and then we will move toward the fully closed loop environment where we want to achieve everything should be automated, and your AI should be able to automate the full cycle of the full working of the network. Okay, inside the TFS architecture, we are working on enhancing the previously monitoring system that we have with the new components in the TFS. Here, my focus will be on the components that is new and that is responsible for the automation of the network. That is the KPI manager. Then we have the analytics. Then we have the telemetry, the automation network, and the policy component. Okay, so what is the SC zero touch service management closed loop automation? First of all, the first step is to observe. So observe means to collect the monitoring data and then to perform the analysis on the monitoring data and then to make a decision on that data and then to execute those decisions onto the network, and then also the feedback loop to make sure that the decision or the execution that you make is able to mitigate the problem. So this is all about the HC closed loop automation. Okay, so first of all, to observe. In the observe, inside the TFS, we have a KPI management and telemetry that is responsible for observing the whole network. First of all, we have a KPI management that defines what to monitor. So you need to define the KPI inside the KPI management, what you want to monitor. And then you also need to inform that from where you want to monitor the KPIs, from the endpoints, from the service endpoint, from the device endpoints, or which endpoint you want to monitor it. And then it is also responsible for maintaining all the KPIs and organizing the data inside the database for the KPIs. Then we have a telemetry component that is responsible for monitoring based on the endpoints. The telemetry which itself will decide which protocol it should use and which data model it should use to get that data from the endpoint. And then it also includes a data streaming platform that is able to support a real-time data streaming of the network monitoring data. Okay. Then we have analytics inside the TeraFlowSDN that is responsible for analysis of the monitoring data. It will, first of all, it will need the input KPIs that you want to process. Then you need to define to mention which algorithm you want to apply to analyze the data. And then you also need to mention that when you want to apply this analysis, either it's a periodic analysis or it's a one-time analysis, or when you want to apply this analysis also need to be mentioned here. And then you also need to define what is the output KPIs, in which output KPI you want your data. Okay, then we have a component that is automation that is responsible for deciding which action to be taken, and it will also decide when to take the action and where to modify the service and which service should be modified to mitigate the problem. And then we have a policy component in TFS that is responsible for applying all these configuration on the network. Okay, this is the internal architecture of the TFS, how different services work with each other inside the TFS. From the top, we have automation on the top of everything that is responsible for implementing this whole closed loop environment. First of all, automation need to create a policy, and that policy is responsible for communicating with all the components to define a closed loop environment. Policy will will also define the analytics function, will also define the telemetry, and will also define the KPIs that is required to implement this function. And then it will also communicate with service and this output interface for the information. And then the telemetry is responsible for collecting all the data from the lower level interface to collect all the data. Okay, so this is the interface that we have for the KPI manager. In this, we have the get KPI descriptor that you can use to create a KPI. Then we have a set KPI descriptor. Then we have a delete KPI, and then we have a select KPI descriptor that you can also use to check for the descriptors that are currently available inside the database. And the bottom, we have a messages types, how you can define your descriptors. Similarly, here we have a definition of the telemetry service where we have a start collector, then we have a stop collector, then we have a select collector to check all the collectors that are available in the system. And the messages, how you can define these collectors. And this is for the analytics, to start analyzer, to stop analyzer, and to select analyzer with all the messages that how these analyzer can be made. And this is for the automation. Actually, the automation is the one that is responsible for directly communicating with all the other components that I explained before. So you need to create a DSM service. If you want to update, you can update the DSM service, then you can delete. And you also want to know what are the services that are currently running to by the function to get by ID or to get by service name. Okay. So this is the internal flow of the services. How, if you want to deploy a ZSM loop inside the TFS, how you can do it. First of all, the service need to communicate with the automation, with the request and all the configurations that you want to deploy inside the network. The automation will receive this configuration, and then the automation will connect with the KPI manager, first of all, to create a KPI. And in this way, the KPI manager will create a KPI and provide a KPI ID to the automation that yes, KPI has been created. Then the automation itself will connect with the telemetry to just create a KPI, to create a collector and provide a KPI ID back to the automation. And then in the next step, it will do for the analytics. Based on all the interfaces that I provided above, it will start collector, it will start analyzer and create KPI descriptor to create all these things. Once it will have all this information, then automation will create a policy. Once we have the policy, to start this closed loop cycle, we need to add the policy inside the policy component. So it will deploy on the network. So the automation will call add policy. Once the add policy is called, the policy component will connect with the telemetry to start getting the telemetry data. Telemetry itself has the independent threads that will run in the background, and it will get the data from the device. As you can see in the step number 12, the telemetry will create a collector and it will respond to the policy in step 13 that it has initiated the subscription of the telemetry data. And then after the 12, we have 14, 15, and 16 that will run in the background and in parallel to get the data from the device agent, from the device, and then to push that data to the message bus. That is our case is Kafka. And then once the policy have the confirmation from the telemetry that it is getting the data, then the policy will start the analyzer and it will request the analytics component to start the analyzer. Similarly, the analytics component in parallel will start analyzer that itself is a background thread that is responsible for reading the KPI values from the Kafka bus. That here we have a message bus analyzing the condition that is defined above in the step number 6, and then publishing the activated flags. If there is any flag that have been activated, it will publish that flag on the message bus on the Kafka. And then policy need to receive these messages, these alarms. So policy will initiate an alarm listener that is responsible for reading these alarms from the Kafka bus and informing to policy component that if there is any activated alarm. Once the policy component is able to initiate the subscription, initiate the analyzer, and initiate the listener, after that, it will inform the automation that the closed loop has been started, and the automation will inform the service that closed loop ZSM service has been deployed successfully. Once the service is running and when we receive a monitoring flag is generated, the analyzer will publish this flag onto the Kafka bus, and at the bottom we have, but we cannot see it here because it is below, the alarm listener will receive a flag from the bus, and it will inform the policy that the flag has been generated, and the decision, it will forward to the decision engine or inside the automation to decide what should be done based on this flag value. So in this way, we are able to completely deploy the closed loop initiation. Okay, so this is the front end of the TeraFlow when we deploy IP over DWDM topology. This is the front end of the end-to-end SDN controller that itself have two bottom controllers. One in here in the black, you can see that here we have a IP controller that is responsible for two IP routers, and here we have a optical controller that is responsible for optical devices such as ROADMs and transponders, and it is connected with them. So in this way, on the TFS, we are able to deploy a IP over DWDM topology, and what I explained, this way the TFS is able to provide to deploy a full closed loop environment according to HCZSM standard. So, okay, the conclusion is IP over DWDM offer a scalable, low latency transport foundation that meets emerging demands. And TeraFlowSDN controller delivers full automation end-to-end network management across IP and optical layers. And SDN controller automation frameworks align with the HCZSM closed loop automation, enabling real-time observe, analytic design at cycle, and to reduce provisioning time. So thank you very much for listening. If you have any questions, you can ask.
Thank you. Any question in the room? Using the mic.
This is Dimitris from ICCS. So, very nice work first.
Thank you.
Congratulations. Is there any netconf definition for the services that you have done? It would be nice to have a netconf like it is in the IPF documents where you deduct the definitions instead of going directly to the it's like the foundation of TFS is based on its own netconf definitions. So it would be nice if you can publish that and make the whole audience, interest audience, aware of how you deal with that. Then it's not very clear to me what are the endpoints of the service that you would like to monitor. Is it a specific address? Is it like in DiffServ? Is it a class-based service KPIs, or is it a specific addresses that you interfaces that you would like to monitor?
Well, we in the telemetry we have different type of. Let me just go to this architecture. Okay. In the telemetry we have different type of protocols. Based on that, it have different sports. If, for example, right now we have the OpenConf GNMI based OpenConfig sport, and we have sport for P4 switches. So in this way, it can support all the endpoints based on OpenConfig models. Like if OpenConfig model will provide us endpoint from devices, we can collect the data from that.
How do you monitor DiffServ classes?
No, not yet.
Maybe let me complement this. For the protocol buffer that you have presented, for
Yes.
policy, for analytics,
Yes.
maybe we put, these are not described using Yang, which I guess is what you requested. We don't have a Yang model for that. We could contribute with the same ideas. We have defined protocol buffers which are more related to how TeraFlow interacts between the different services. I think that we could contribute this kind of thought maybe to CTTC. If they are, I don't know if they are thinking with an API, but at least this could be contributed. In fact, my question, I have a question for Waleed, is will this be applied somewhere, this CTTC model, in some kind of proof of concept, and can you detail a little bit more on this?
Yes, we are working on one of the projects to deploy these things inside our flex scale project that we are working, where we want to deploy this whole ZSM closed loop and try to see that in which level we can deploy this thing.
Let's just put the rest of line because timing, we're in a good time.
Okay.
We have a lot of presentations today, so let's use the coffee break for the more detailed questions.
Okay, thank you very much.
So let's thank the speaker again.
Thank you very much.